Transformer secondary conductors can indeed be tapped. While secondary overcurrent protection isn't explicitly mandated for the transformer itself, it's crucial that all loads connected to the secondary conductors are adequately protected against overcurrent. You can implement a system where a single set of conductors runs from the transformer secondary to a wireway. From this wireway, you can tap into smaller conductors to supply multiple molded case circuit breaker, or MCB, panel boards. However, certain conditions must be stringently adhered to. The total length of the conductor, measured from the transformer secondary to the farthest panel board, must not exceed 10 feet. The wireway size must be appropriately calculated to accommodate the quantity and size of conductors it houses. All taps and terminations must be executed within approved enclosures or junction boxes. Crucially, overcurrent protection devices must be put in place to safeguard the smaller conductors that feed the panel boards. Employing taps on secondary conductors offers several advantages. Firstly, it can lead to reduced expenses related to both materials and labor by negating the need for multiple feeder runs. Secondly, it introduces flexibility, simplifying potential future alterations to the electrical system. Thirdly, it establishes a centralized hub for overcurrent protection and maintenance activities. If the transformer's secondary current surpasses the ampacity of the tapped conductors, it becomes necessary to establish separate feeder runs. Always adhere to the National Electrical Code, or NEC, and the manufacturer's guidelines for accurate installation and overcurrent protection. Let's delve deeper into each of these aspects. First, the NEC guidelines are paramount. They ensure safety and code compliance. Consult the latest edition of the NEC for specific articles related to transformer installations and conductor sizing. Second, conductor sizing is crucial. The main conductors feeding the wireway must be sized to carry the total load of all the panel boards they supply. Use appropriate ampacity tables, such as those found in NEC Table 310.15, to determine the correct conductor size based on the load and the conductor's insulation type and temperature rating. Third, overcurrent protection is non-negotiable. Each panel board must be protected by an overcurrent device, such as a circuit breaker or fuse, sized according to the ampacity of the conductors feeding that panel board. This protection should be located at the point where the smaller conductors tap off the main conductors in the wireway. Fourth, wireway considerations are essential. The wireway must be large enough to accommodate all the conductors and their associated insulation without overcrowding. The NEC specifies fill limits for wireways, typically expressed as a percentage of the wireway's cross-sectional area. Ensure the wireway is properly supported and grounded. Fifth, tap rules must be followed meticulously. The 10-foot tap rule is a critical safety measure. It limits the length of the unprotected conductors to minimize the risk of damage and fire. If the tap conductors exceed 10 feet, they must be protected by an overcurrent device at their point of supply. Sixth, termination methods matter. Use only approved connectors and termination methods for all conductors. Ensure that all connections are tight and secure to prevent overheating and arcing. Torque all connections to the manufacturer's specifications. Seventh, documentation is vital. Keep accurate records of all conductor sizes, overcurrent protection ratings, and wireway specifications. This documentation will be invaluable for future maintenance and troubleshooting. Eighth, safety practices cannot be overemphasized. Always to energize the transformer before working on any conductors or connections. Use appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and insulated tools. Ninth, consider voltage drop. When designing the conductor system, calculate the voltage drop to ensure that the voltage at each panel board remains within acceptable limits. Excessive voltage drop can cause equipment malfunction and reduce performance. 10th, grounding is critical. Ensure that the transformer, wireway, and panel boards are properly grounded according to the NEC requirement. Grounding provides a path for fault current and helps to prevent electrical shock hazards. Let's elaborate on the implications of exceeding the ampacity of the tapped conductors. If the transformer secondary current exceeds the ampacity of the tapped conductors, it means that the conductors are not capable of safely carrying the full load that the transformer can deliver. This situation can lead to overheating, insulation damage, and potentially a fire hazard. In such cases, separate feeder runs directly from the transformer secondary to each panel board are necessary. Each feeder run should be sized to carry the load of the panel board it serves, and it should be protected by an overcurrent device at the transformer secondary. This ensures that each panel board has its own dedicated source of power and is protected against overcurrent conditions. Understanding the NEC Article 240.21 is paramount to grasping this concept. Article 240.21 of the NEC addresses the overcurrent protection of conductor taps. It provides specific rules for when and how conductors can be tapped without requiring overcurrent protection at the tap point. The 10-foot tap rule is one example of these rules. By following these rules, you can ensure that the conductors are adequately protected against overcurrent even though they are tapped from a larger conductor. For example, if you have a transformer with a secondary current of 200 amps and you want to feed two panel boards, each with a load of 100 amps, you would need to run separate 200 amps feeders from the transformer secondary to each panel board, each protected by a 200 amp circuit breaker. Alternatively, you could run a single 200 amps feeder to a wireway and then tap off two 100 amps conductors to each panel board, provided that the tap conductors meet the requirements of NEC Article 240.21, including the 10-foot tap rule. In addition to the 10-foot tap rule, there are other tap rules in the NEC that may be applicable depending on the specific installation. For example, the 25-foot tap rule allows for longer tap conductors under certain conditions, such as when the tap conductors are enclosed in a raceway and are protected from physical damage. Always consult the NEC for the most up-to-date and accurate information on tap rules. Remember, the primary goal of overcurrent protection is to protect the conductors from overheating and potential fire hazards. By following the NEC and using good engineering practices, you can ensure that your electrical system is safe and reliable. Therefore, tapping transformer secondary conductors can be a viable solution for distributing power to multiple panel boards, but it requires careful consideration of the NEC conductor sizing, overcurrent protection, and other factors. Always consult with a qualified electrician or engineer to ensure that your installation is safe and code compliant. Now let's consider a practical example to illustrate these concepts. Imagine you have a 480 volts to 208 volts / 120 volts transformer with a secondary current rating of 150 amps. You need to supply power to two panel boards, each with a calculated load of 60 amps. You decide to use a wireway to distribute the power. First, you would run a set of conductors from the transformer secondary to the wireway. These conductors must be sized to carry the total load of both panel boards, which is 120 amps. According to NEC Table 310.15, you would need at least number 1 American wire gauge (AUG) copper conductors with a 75 degrees Celsius insulation rating. Next, you would tap off conductors from the wireway to each panel board. These conductors must be sized to carry the load of each panel board, which is 60 amps. According to NEC Table 310.15, you would need at least number 6 AWG copper conductors with a 75 degrees Celsius insulation rating. You would then install overcurrent protection devices at the point with the number 6 AWG conductors tap off the number 1 AWG conductors in a wireway. These overcurrent devices should be sized to protect the number 6 AWG conductors, which have an ampacity of 55 amps. Therefore, you would use 50 amp circuit breakers for each panel board. Finally, you would ensure that the total length of the number 6 AWG conductors from the wireway to each panel board does not exceed 10 feet. If it does, you would need to install overcurrent protection at the transformer secondary to protect the number 6 AWG conductors. This example demonstrates how to apply the NEC requirements for tapping transformer secondary conductors. By following these guidelines, you can create a safe and reliable electrical system that meets the needs of your application. In summary, tapping transformer secondary conductors is permissible under specific conditions outlined by the NEC. These conditions primarily revolve around conductor sizing, overcurrent protection, tap conductor length, and proper termination methods. Always prioritize safety and code compliance when designing and installing electrical systems. The National Electrical Code provides a comprehensive set of rules and guidelines for electrical installations, and it is essential to follow these rules to ensure the safety of people and property. When working with transformers and secondary conductors, it is crucial to understand the NEC requirements for overcurrent protection, conductor sizing, and grounding. By adhering to these requirements, you can create a safe and reliable electrical system that meets the needs of your application. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician or engineer before undertaking any electrical project. They can provide guidance on the NEC requirements and ensure that your installation is safe and code compliant.